In this video we'll see how to do the full hypothesis testing procedure using Excel and using the z-test. So I'm going to create a spreadsheet that will calculate and display and organize everything we need. Let's just start by labeling it. So we're testing the mean here. And this is where the population standard deviation is known. We're looking at example 9.14 from the book, and here's where you're not given sample data, rather you're given summary statistics. I'll show how you can easily adapt this for using sample data. And we'll start with the hypotheses. So we need a null and alternative hypothesis. And we're testing the mean, so we're going to use the lowercase Greek letter mu. Now, to determine the inequalities, we need to find the claim in the problem and then translate that to a hypothesis. You had some experience with that in the previous unit, and here we can actually see that there's a claim by Frank that the goggles help Jeffrey swim faster than the 16.43 seconds. So the claim is that mu, which represents the population mean of Jeffrey swimming with the goggles, is going to be less than, he's swimming faster, the time is less than his previous average time of 16.43. So that creates that alternative hypothesis. And then we use the same number in the null hypothesis, and we now have a set of hypotheses. From this we can ascertain the type of test. In terms of the direction, this is a left-tailed test. That should be apparent from the inequality in the alternative hypothesis, pointing to the left. The type of distribution we use is next. And we'll be using the normal distribution since the population standard deviation, which is represented by the lowercase Greek letter sigma, is known. Next we're going to state our level of significance. We know that's represented by the lowercase Greek letter alpha. And we're told that that is 0.05. We can now record our sample statistics, which will summarize the sample that we're not actually given. Since it's a test for the mean, we should have a sample mean and sample size, we always have that. And then a standard deviation is usually given in these mean tests. In this case, it's the population standard deviation. Alright, so the sample mean is 16. Oh. Yeah, so sample mean is 16. It says Jeffrey's mean time was 16 seconds. The sample size is 15. It says for the 15 swims. And the population standard deviation is 0.8. So 0.8. Alright, we're now going to adjust the standard deviation to get the standard deviation of the sampling distribution. And remember from experience 8 that is found by taking the population standard deviation and dividing by the square root of the sample size. Now Excel will do that for us. Right. And we're now ready to calculate a p-value. This is a left-tailed test, so we will have the left-tailed p-value, but so we can do fewer examples and generalize what's going on, I'm going to go ahead and put in the formulas for all the p-values. And so we're using the normal distribution, and we want the area to the left for a left tail. So do norm dist, and then the mark off for the tail is going to be the sample mean. The mean of the sampling distribution is the hypothesized population mean, and the number that shows up in the hypotheses. The standard deviation is the adjusted standard deviation, the one for the sampling distribution, because that's where the p-value is represented. And in cumulative, we're going to use 1. So that gives us the left-tailed one. Now, if this were a right-tailed test, we'd want to get area to the right. And so then you'd need to do 1 minus the same formula. Right? Norm dist default finds area to the left, and the total area is 1. Area to the right would be 1 minus the norm dist. So we're just going to put this stuff in. So you can change these values later if you want. X, there, and 1. So there's right-tailed. Now if it's a two-tailed test, you would have done the left tail to the right tail based on which side that sample value was from the mean, and then you would just double it. And since the p-value is usually the smaller of these two, I'm going to go ahead and say this will work most of the time. But of course, double check that kind of thing. Of course, the one we're using for this problem is the first one, just so you can reuse the spreadsheet later. Now, we want to get a picture of this p-value so we know what's going on. Let's go to that online tool, which is linked from the Experience 12 folder. We're going to get area from a value. P-value is an area. The mean would be the number that shows up in the hypotheses. The standard deviation is that adjusted one. It's the same numbers we used when we put them into norm dist. And we'll just round that to 207. And then in left-tailed test, we would want below left 16. And recalculate. So we can now get a nice picture of this. And then we'll put that there. And that is, it's a little too big. Alright, that looks pretty good. So there's a picture of the p-value, which is something that you're asked to do in the application. And I think this is the ideal way to do it. You, of course, hand draw this. You should have something similar drawn and then have this labeled where you're marking off the tail.
Okay.
Of course, that tail is marked off at 16 because 16 was the sample mean. And the area of that tail is the p-value. So if you do a hand-drawn graph, mark off where that tail is with 16, and then mark off the mean in the middle. Alright. Actually, you know what? To make this look right, let's just grab all this. That way, I will know if you did it right. So go ahead and just take a screenshot or a snip of the whole thing. That way somebody can easily check your work. So now we know it's the area below 16, and we know what that area is. And we can see that the correct mean and standard deviation are being used. Alright, decision time. So remember the decision, we compare the p-value with alpha, and the p-value is about 0.02 and alpha is 0.05. So we'd say since p is less than alpha, we reject the null hypothesis. Alright, now we got to have a conclusion which relates this decision to reject the null back to the original claim. Remember that the original claim was a claim made by Frank that the goggles would help Jeffrey swim faster, and that corresponded to the alternative hypothesis. Since we rejected the null, we actually do have evidence to support the alternative, and we could say the following. Sample data supports the claim that the goggles helped Jeffrey swim faster at the 0.05 level of significance. So something along those lines. Alright, and that's a complete hypothesis test for this problem. Now, you could also do this same z-test for the mean where you were given sample data. And how would this differ? Let's take a look. So, in the situation where you're working with sample data, you would still diagnose your hypotheses and the test, and the type of distribution, level of significance. But when you get to sample statistics, you would have to calculate these. So we're going to go ahead and create a column here where you'd actually put in the sample data. And you would have to paste in the numbers here. So I'm just going ahead and put in a bunch of numbers that have this. So 16. And let's get 15 of those, right? So here's 15 numbers, and the sample mean is 16, just so the numbers actually match up. In general, you'll have a list of data there, and then the sample mean will be average, and then we'll just go ahead and select that. I can go way down here and not really cause any problems, and that way, if I have a longer data set later on, you know, as long as it doesn't go past the row 119, it'll just include those numbers. And when you have those blank cells, it doesn't include the blank cells. So that'll work really well there. The sample size can be a formula too. The count function will do the same thing. It'll just count these. And it just counts the ones that have numbers put in there. So you can now overwrite this. Remember, if you put in a shorter data set, you'd want to delete the additional numbers that you weren't overwriting. Everything else is automated. You were given population standard deviation for the z-test, and then this formula is automatically updated, and the p-values are automatically updated. So you would just be changing that. All right. And this is the z-test. So maybe you followed along and you've created one of these. Maybe not. I provided this as a model spreadsheet that you can edit. And I've shown which cells should be edited and which should be left alone, as some are just calculations. Look forward to the next video where we'll be looking at doing a t-test with Excel.